Hello and welcome to this next video on basic electrical repairing. In the earlier video, we were talking about conductors and insulators, and we spoke about different types of wires and how the conductor and insulator are placed in these wires. In this video, we will also take this discussion forward by trying to understand a little more about different types of conductors and insulators using some of the common elements or equipments that we normally find in the electrical trade. Now, first of all, let's take this electric bulb. The bulb has a filament inside it, which is actually a conductor of electricity, and the outside has a glass component. This glass is actually an insulator. It does not conduct electricity, whereas the bottom 2 points that you see, or the metal points that you see here, are good conductors of electricity. And so while you're working in an actual line, if you touch any of these, you will get an electric shock. In between these 2 points, the black color thing is actually a cork, which is a good insulator, and that ensures that the 2 points do not come in contact with each other. Now, inside the bulb, there is a very thin filament which is made of tungsten. Tungsten has very high resistance to electricity, and that is the reason why the filament heats up when electric supply is passed through the filament. And as soon as it heats up, the gas which is inside ensures that the light is displayed out. The gas inside is called argon, and that ensures that the bulb illuminates and the light is spread out evenly through the bulb. So you can see very clearly there is a tungsten filament inside, which is what causes the light. It has high resistance, and that's why it heats up when electric current is passed through. So this tungsten filament is actually a good conductor of electricity, whereas the glass outside is a very bad conductor, or in other words, it's an insulator in a bulb. The other thing that we see here is a bulb holder. The outside part is a PVC part, or sometimes made of plastic. So this is an insulator. It does not conduct electricity, whereas the inside metal parts that you would see here are actually conductors. And so while you're working in the electric line, you must not touch any of these inner parts here, because these are conductors of electricity and can result in an electric shock. So when you're working on this, you always hold it by the PVC end and not with any of the metal points on the bulb holder. So the outside part is an insulator, whereas the inside metal part is actually a conductor in a bulb holder. Moving on, this is a small piece of wood, and wood, I am sure all of you understand, that is a very bad conductor of electricity. In many instances, while doing motor winding and other cases, we use the wood as a good insulator to ensure that there is no power supply from one part to the other part of the motor. Another such insulator is the leatherite paper. Leatherite paper is also an insulator. In motor winding, we use this commonly. This leatherite paper has capability to withstand very high level of heat, and it will not burn up in very high temperatures, and that's why we use the leatherite paper while doing motor winding. These papers come in very different thicknesses of 7 mm, 8 mm and so on and so forth. So depending on the motor that you are working on, you can pick and choose a particular leatherite paper, because this acts as a very effective insulator, and it ensures that 2 wires don't come in contact, or even if they come in, if they are very close to each other, the leatherite paper acts as an insulator, preventing the flow of current from one wire to the other wire. One more similar paper is called a PVC paper. This is made of PVC, or polyvinyl chloride. This is also a good insulator, and this is wound around the wires while you are doing motor winding. This again comes in different thicknesses, and you can pick up the respective thickness depending on where you want an insulator, or where you want some part to be insulated completely from the other parts. This wire is used in motor winding to ensure that the coil does not come in contact with the body of the motor, and thereby avoiding any short circuit of the entire winding. Now, these are called slips. Slips come in again different sizes, different thicknesses. So when you are making joints between 2 wires, we use a slip to cover those joints. This ensures that the joints are intact and they are insulated properly. Typically when you are making joints, you have to remove the insulation from the wire. So after you remove the insulation from the wire, you place the joint inside these slips. And these are typically like straws. So when you put them inside, these function like insulator, ensuring that the electricity supply is not carried outside of the wire. Now this is a coil of an electric iron box. Here we have used something called as a nichrome wire, which is again a very good conductor of electricity. It also has a very high resistance level, thereby ensuring that it heats up the metal that it is wound around. Underneath is mica. Mica has very high resistance to heat, and that's the reason why mica is used as a good insulator and is typically found in most of the iron boxes. So the top part has nichrome winding, and that heats up the conductor part, and underneath is the insulator, which is made of mica, which ensures that the heat is transferred to the metal surrounding it without melting. This is cotton thread. Cotton thread is again another good insulator. You can use this for winding around wires. In earlier days, insulation used to happen with cotton wires, but nowadays we use mostly PVC and other rubberized insulation. This is a tape which is commonly used in electrical thing. This is also made from PVC. Whenever you are joining two wires or making joints, we cover the joint using the PVC tape to ensure that the joint is protected and it does not conduct electricity outside of the joint. It is also commonly used in a lot of circuits. It is a good insulator. Apart from these, a few other insulators such as these cardboard paper that you see at the back are also very common in electrical trade. The cardboard basically is a very good insulator and prevents electricity from getting transmitted from one point to the other. So you can use this as a blocking point to ensure that two wires don't come in contact with each other while they are in a circuit or while they are in an appliance or an equipment. So these are some of the conductors and insulators as we saw in these two videos. Now there are a few other insulators that are essential from a safety perspective, especially while you are working with electrical equipments or electrical line. Number one is you must always wear slippers or shoes while you are working on electric line. This is because the shoe or the slipper acts as a good insulator and prevents electricity flowing through your body to the ground. If there is a faulty line and electricity finds a way to flow through to the ground, typically if you are not wearing a slipper or a shoe, it can result in an electric shock to your body, and that is why it is important to always wear shoes or slippers while you are working in the electric line. You can also use stools or short tables made of wood or plastic while you are working on electric lines, because wood or plastic are also insulators, or in other words bad conductors of electricity, and can prevent or save you from an electric shock. So in summary, a conductor is something which allows electricity to pass through it, and insulator is something that prevents electricity from flowing through it or does not conduct electricity through it. Most metal items typically are conductors of electricity. There could be some exceptions, and other items such as plastic, glass, polyvinyl chloride, PVC, piping and so on are typically wood are bad conductors of electricity and can be used as effective insulators. Now among all conductors, the best conductor is probably silver, but obviously silver is a very expensive thing to be used in wires, and hence we use copper and aluminum. Copper is the next best conductor, and aluminum is the third best conductor of electricity. One other thing you must understand is that you should never have wet hands while working on electricity, because water is again a very good conductor of electricity. We do hope you would have understood a lot about conductors and insulators in these two videos. Let's keep learning. Thank you.